Hello and welcome. This is question 3 for January 2003 at Edexcel M1. So this question is all about vectors and force resulting from Newton's second law. Okay, so what we've got here is we are given a particle. It's got a mass of 0.4 kilograms. There's a force being acting on it. We don't know what that is yet. Obviously we're going to end up working that one out. So we're given that the initial velocity is 6i take 27j meters per second. So that means that you could either write that as 6 as a column vector, so 6 minus 27, or leave it as that. I leave it as that. V is minus 14. So the final velocity after t of 4 seconds, after a time period of 4 seconds, is minus 14i plus 21j, and we're asked to find out a. Now, obviously you know the acceleration formula off the top of your head by now, but I'd still write it out. So v equals u plus at, so that's one of the Seebeck equations. Rearrange that to get a, so that's v take u over t. Also, it makes you look like you've done a bit more thinking than you actually have, so everything's a bonus. So a is equal to v take u, so just put it in bracket form, don't need to change anything about it. So 14i plus 21j. Don't forget the little squiggles underneath. Make it vector. Take away 6i minus 27j. Okay. I keep it in brackets because otherwise you might miss out the double negative there. That's over 4. So first thing you'd do, you'd show you're working out of simplifying them all down. So therefore it'd be a is equal to, take the I, so minus 49 minus 6i, minus 20i, plus, so that's minus 14, that's 21j, take minus 27j, so it's 21j plus 27j, so that's 48j. Okay, that's all over 4, so you divide each term by 4, so that's minus 5i, plus 12j. Okay. So that's your answer to part A. Now that's the acceleration vector, remember. It's not anything other than that. Right, so that's the acceleration vector. However, could you accept it? Yeah, so you do, that is the acceleration vector. However, for this next part, we're going to have to do something with that. Okay, so I've written the key bits of information down for you. So basically, we're asked to work out what this force is. So I gave it straight away because I didn't think there's no way of building up to it. That is what the only thing in mechanics that uses force, maybe apart from equilibrium, but this isn't that. So anyway, what we're using is force equals mass times acceleration. So that's resultant force, remember. So there's nothing pulling it this way, so we only consider that force. So it's obvious stuff. Now you know resultant force is equal to mass times acceleration. We know the mass, we don't know the force, but we know the acceleration now. However, that, remember, is the acceleration vector. So we can't simply do 0.4 kilograms times 5i plus 12j. No. It's a, to work out the magnitude of a, you do Pythagoras' theorem, which is obviously minus 5 squared, so that'd be 25 squared, plus 12 squared, which is 144, which is the square root of, have I done that? Someone said, I'll check if I've actually done that right. Yes, that's the root of 221, I think. Basically it's 13. Made a mess of that. Sorry, no, it's not 221. What was it going on about there? Anyway, so that's a blooper for you. It's been a tough night, any sleep, so I can count that out. Literally no sleep. So anyway, 13 meters per second. Don't forget that's meters per second squared. Probably shouldn't be revising, but death to all and such. Resultant force equals mass times acceleration, so it's 0.4 kilograms times 13 meters per second squared. So therefore you get a force, resultant force I should say, of 5.2 newtons. Okay, so that's your end answer. Sorry about making a little cock up there. I did this wrong before and I got root 221, that's what my mind was. Because I made a mess of doing something over there, I had no idea what I did. But anyway, that's how it should be done. as I said, you could really just work that out from the mark scheme. There's nothing more that I could explain apart from maybe giving you a diagram and telling you the way to work it out, which is kind of the whole reason you're watching this video, but you know. Anyway, so as I said, hopefully that's helped you out there to some degree. Right, standard stuff. You know, just let me know if you need any help. Have a go at that question again. I'm more than willing to. So anyway, thanks for watching, and we'll see you in the next video.